Welcome to the Orthogonal Bet, where we explore the weird and wonderful ideas that shape our world. It's a cabinet of curiosities for the ears and the mind. I'm your host, Samuel Arbesman, complexity scientist, author, and scientist in residence at Lux Capital. In this episode, I had the pleasure to speak with Paul Rony. Paul is the founder and CEO of Kosmik, a tech startup based in France. Paul is also deeply knowledgeable about the history of computing and the ideas that animate it, and I wanted to discuss these ideas with him. Paul and I had a chance to discuss how he became interested in computing history, his own experiences with older computers, and the importance of the intellectual history and ideas that suffuse these technologies. We talked about the value of playing with old computers, the changing nature of programming, and of course, we talked about HyperCard, one of the wildest pieces of software ever. This conversation was a ton of fun, and I had a great time speaking with Paul. Let's begin. Paul, great to be chatting with you, and welcome to the Orthogonal Bet.
Thank you. Thank you for having me. It's a pleasure to be here.
Yeah, I'm super excited. You and I both love talking about computing history and the nature of technology and how it relates to kind of the more human aspects of the world. And I want to do all of that, but I think maybe first we should just begin with, if you could share a little bit about your own background and kind of how you got into the world of computing and grew to love it.
So yeah, my life in computing began with computing history. So basically when I was about 8 years old, I wanted a computer. I had two older brothers and they were getting into college. So I wanted to, do the same and have my own computer. And my parents felt I was a bit young. But my uncle at the time was, emptying a garage, I think. And he had an Atari ST from 1985 that was lying around. He was a musician. The Atari ST, we may talk about that, but was a computer that was extremely popular with musicians because of its MIDI input-output system. And so he gave it to me. And it came with only one disk, which was the GFA basic disk. So I had to learn to program to use it. And I was fascinated by that computer. And it just opened my mind to the fact that, yeah, computers did not have hard drive. And it's not necessarily the default to have a desktop. And oh, of course, you can program it. Oh, if I want to play game, I can just, put a disk inside and there's no need to install it. And so it felt limited, but also very liberating as an experience. And so I don't know if you want me to tell you more details, but basically the short story is at some point I wanted more software for my Atari computer, which of course was not easy to find. And so I joined a nonprofit organization that still exists in France, mo5.com, who is preserving the history of video games, microcomputing, and more broadly what they call digital culture. And so I became one of the members of MO5, and that allowed me to touch almost all of the machines from the microcomputing revolution.
Oh, I love this. And so just to kind of give me a sense of it, like what year did you first get this Atari to kind of like understand like what was like the current technology versus kind of the technology you were working with?
So to give you an idea, the iMac G4, the one that could move around, that looked like the Pixar lamp, had just come
the
out.
lamp one, yeah.
So it was in 2002, I think.
Okay.
Yeah. So I was 8. So yeah, that was 2002.
Okay. So in 2002, your first computer was an Atari from 1985. Okay. So it was like,
yeah.
So like you were living computing history rather than just kind of like as a very academic thing. Like that was like, it was for you, it was very tangible and real because that was the only computing experience you had.
Exactly. And I could use the family computer, which was an iMac at the time, but it was not mine. And of course, my father had work to do and it was the family computer because at that time we shared the computer back in those days. And so the Atari was in my room and I had my discs and afterwards I found a printer for it. And I think it's the exact same experience you have when you're a teenager and you get a very old motorcycle. It's not, you can fine tune it. It's not working super well, but it's yours and it still go places and it go exactly where you want to go. So yeah.
Yeah. So you had this family computer like an iMac, and then you also had this Atari. What were and you mentioned there's kind of like both upsides and downsides to both like different kinds of technologies. Like what were the things, I mean, I imagine you were able to very clearly see the trade-offs in both of these.
Yeah.
Because I feel like a lot of people, when they are comparing like older technologies, it's often through the benefit of hindsight of like, because you've often kind of gone through multiple things in between while you're kind of, you're comparing and contrasting things that are almost like 2 decades apart, like at the exact same time.
Yeah, and so my second computer was a Macintosh SE, and then the third one was a Next Cube. So
and so were these all old computers from your uncle?
No, some of them I began a collection basically. Okay. I began to buy them, or you could now people would pay a fortune for a Mac SE. But back in the early 2000s, people would just, put
They
them on
just
the
give them
street.
away. Yeah, and that was
Yeah,
and the Mac SC was my family's first Macintosh. Like, yeah, we went from so our family's first computer was the Commodore VIC-20, and then we
yeah,
went from there to the Mac SC. But then
that's a
and
jump.
I remember finding it like years later, like in our basement, and like playing with it, and like it was great. But it was very much like not the cutting edge kind of thing.
I think for me, what I love, if you think about the Atari as a computer, the OS is in ROM, so it boots instantly, which looks kind of like a MacBook Air. Did not have a hard drive, so you have to go through external media. So basically, when I turned it on, it would look for a disk in the floppy disk drive. If it did not find one, the desktop would appear, the green desktop of the Atari ST, and then from there it looked kind of like a Macintosh. And so, to your example, if I go back to the VIC-20, I think the difference between a VIC-20 and a Mac SE is actually greater than between a Mac SE, for example, and an iMac from the early 2000s. Like those things
Interesting.
use the same metaphor. You have folders, you have windows, you have pull-down menus, you have apps and documents. The ST also has those kind of things, but it was not as professional as the Mac. What I remember as a very cool experience was just popping in a floppy and the computer would become that software. Software would take over, games would take over. There would be no desktop. Like the cursor would change, everything would change. And that looks and feels like the early iPad, for example. I remember distinctively when the iPad came out and people reviewed the iPad could not multitask. It was impossible. You had to go to the home screen, app had to reload. And on the ST, I had that same experience. And I think for me, it has one benefit, which is that you're immersed in the task you're actually doing. When I was using Neochrome, which is a drawing software, I was actually just drawing. When I was writing, I was just writing. I think that we've forgotten about two things from those days. The insular experience that was the computer. The computer was not tied to any kind of network. So the outer world could not get to you in any way. The iMac of my father already had emails, and it was already connected to the web. And the other thing is those very, I would say, non-multitasking experience. And even if you look at the very early systems that had preemptive multitasking, I think the first microcomputing to have real preemptive multitasking is the Amiga from 1985. The applications actually thought, that on the Amiga, you can pull the top of the screen to reveal another app. All the apps would run in full screen. So I think all of those experiences, for me, it was really interesting to compare and to see how the Mac of my father actually looks like a blown up version of that ST with more colors, more memory. It can do more things, but it's also more complicated. And one thing that I remember vividly is that those computers would crash much more than my ST. Like my ST would never crash, never. And it had that reset key, that you would press on the back, and it would just reset the computer and no problem. So of course you have all of the other things, like if you forget to save, it's dead. If there's a power outage, it's dead. But it was a very refreshing experience. And I think for me as a kid, I was very lucky because I had my own computer. It felt like a model version of the grown-ups computer, but it could do music, it could do painting, it could do animation. I programmed games on it.
It's amazing.
It was, I think, and also one thing that I think is very, and I know you care about that too, but the documentation that was available for that machine was absolutely outstanding. Like the manual of GFA Basic is absolutely, still today, I think is an example that people that write documentation should look at. Just like the early manuals of Mac Paint and Mac Write are a work of art. And right now, when, we always talk, I know you also work with a lot of startups. In startup land, we always talk about the onboarding experience. And the onboarding experience is super hard to get right, especially when you're trying to have a complex software to convey the richness of that experience, because we cannot fall back to the manual where people, could go from one section to another and learn progressively. So yeah, I think those were distinct, differences between those two experiences.
I love this. And also when you're talking about like the lack of multitasking in some of these early computers, or sometimes multitasking, but kind of they took over the screen and kind of made you feel like, okay, this is like the purpose of the machine at this point is this single use. And people have tried to recreate these. Like there's like either software or sometimes people even building like special purpose hardware to basically recreate the experience of these much simpler but still very elegant machines. And then we realize like, yeah, we've lost something in the ability that, yeah, we can do lots of different things at the same time. The downside is though, is that we can do lots of different things at the same time and we can't focus on a specific thing. And so having that that single use piece of software or function is really, really vital. And I think we realize that we actually need that
Yeah.
as humans.
And I think this is one of the problems with, I think in the 80s when people were clamoring for multitasking environments, I think, and from when you read the publications, the magazines, I think what they were really asking for was a way for the computer to be able to copy a floppy while you're doing something else, which the Mac before OS 10 had a hard time to do. Like Windows was much better on multitasking. And when we got proper true multitasking through the Amiga, then through Windows 95 and those software, the metaphors that are underpinning the system, Windows, the overlapping windows, the file system, were never readapted. We're like, okay, now we have multitasking. And we never thought of all the implications. The fact that you switch from, because on a desk, on a real desk, when you have, I don't know, a spreadsheet and just a notepad, they actually operate in pretty much the same way. And you're going to use the same highlighters, the same pen, the same ruler. You're going to use the same tools. On a computer, because again, we have that app-oriented paradigm, the tool palettes are not in the same place. The commands are not exactly the same. And so I think we lacked that moment of pause where we should have said, okay, now the computer is going to be able to do 10 things at once, and not only background things like running a daemon, to get a state somewhere. No, it's actually going to allow me as a user to basically drive. To me, it's the equivalent of trying to drive 3 cars at the same time. So I think multitasking is not the problem, but the slightly different user interfaces and experiences and metaphors used throughout the programs are really creating those issues that make people believe that it was better in the 80s.
Oh, it's interesting. Yeah, and so actually related to like the different metaphors and user interfaces, like I know like when the Macintosh first was released, there was a very clear set of guidelines and even
Yeah.
like programming tools to kind of make sure that software that is built for the Macintosh looks all the same and kind of feels the same. And so you kind of know, and like when you press Command S, it's going to save, and there are all these kind of different things to make things more consistent. And of course, people can make software that is not necessarily that consistent. Do you think that kind of thing was necessary? Have we kind of lost that sort of uniformity of approach to user interfaces? How do you think about that?
I think several things happened. The first thing that happened when the Mac came out is that, as you said, they came up with the guidelines, and they also came out with, again, the documentation was extremely precise in how you should handle the ROM, how you should handle the commands, how you should handle the toolbox. And this is when you compare the 1632 bits microcomputers of the 80s, like the Sinclair QL, the Atari ST, the Amiga, and the Macintosh. Even if you look at the ST and its ROM, it is not as refined as the toolbox from the Mac, where you can really make super complex calls. And Apple, Andy Hertzfeld and Bill Atkinson gave great, I think, they left us great testimonials about that. They tried to make that as easy to do as possible. And at the time, you also had people that came to Apple a bit afterwards, like Bruce Tognazzini, Tog, as he was nicknamed, who encouraged developers to drop the flowchart. And so I think one thing that the Mac that was the first platform to do is it encouraged developers to not rethink the basic button. Use the button from the toolbox. The radio control, use it from the toolbox. You should design only the part of your app that are necessary for you should only build what is not built in. And I think right now, when I look, for example, at the triumph of web-based technologies, I don't know a single designer that hasn't redesigned a pull-down menus, a contextual menu, or those kind of elements. That's super bad. It's bad for accessibility. I think it's bad for businesses, because I think if you look around, like Rasmus Andersen, who worked at Figma, he said that redesigning the pull-down menus, the contextual menus, like just trying to get that experience to feel right, took him 1,000 hours of man hours. And so I think it's madness. And I think the Mac actually enforced those guidelines extremely beautifully, because it was not, you were nudged towards using that. And I think Apple was, they were extremely, how can I say that in English, careful in the way they added stuff, in the way they thought about the system and the commands. And if you look, for example, at the history of HyperCard, one thing that made Jean-Louis Gasset, who had become head of R&D at Apple at the time, not super happy about HyperCard was that Bill Atkinson, because he had worked on the first ROM of the first Mac, felt that he could change the primitives. Like Command S maybe is not safe. Maybe now we have autosave, and so we can take Command S and use it for something else. And Jean-Louis Gasset felt that it was not a good idea because HyperCard would introduce those different, patterns in the Mac experience, and the Mac at the time was still relatively new. I don't know if that answered your question, but
No, this is great. And yeah, and I guess related to that then, how do you think about, I mean, because on the one hand, one of the exciting features of the web is the kind of like sort of open and distributed nature and kind of just like the sort of like the ground up way in which things are kind of innovated. On the other hand, though, because of that, the downside is right, everyone is reinventing all these different ways of interacting. Like, do you have a sense of like what the path forward might be to kind of make a more uniform sort of experience, but without necessarily feeling as if like people are kind of demanding certain things from the top down and kind of squelching a certain amount of bottom up innovation?
Yeah, I think now that what I said is fortunately less true. You can use great frameworks, like TipTap for text, and they will come with everything you need out of the box because those people are solely working on that problem, or Radix components, like you have those things. So I don't know what the path forward should be. What I'm worried about is that the native experiences, like when you're coding for Apple platforms, have actually gotten slightly worse. With the introduction, when UIKit came to the Mac through Catalyst, and when SwiftUI was then introduced by Apple, SwiftUI should have been that, unifying framework. And it probably will be because Apple has the resources and they know how to get those things right. But for 5 years, like when Swift was still changing a lot, actually native development could feel as unstable, if not more, than web development. So I think the path forward is maybe through AI coding agents that, it's funny because AI coding agents, I don't know, they come with some, how could I say that, preconceptions. They're
Right.
not born completely anew in the world. Like they know what is Vite, they know what is a bun, they know how to set up a project. And so I think that because beginners will flock towards that new, that new far west of malleable software, I think we're going to see standardization happening on technologies that agents know how to handle, like what's happening with Supabase for vibe coding apps, or again, what is happening with all of those technologies to set up a good JavaScript-based project in a matter of minutes. So I don't know if it will be good in terms of experience, but I think at least the common ground now will probably be set.
Oh, that's really interesting. So, I want to go back to like the computing history. I mean, you and I both love talking about this kind of stuff, and you're obviously very deeply versed in it. I mean, I feel like when people talk about computing history, often it's from not only, but often it's from like a sense of like nostalgia of like, oh, remember this when I was younger, and I feel like the way you're talking about it though is very, very different. It's much more of, okay, there are great things to be learned from all different moments in computing history, and kind of like, let's find the things that are the best from these different moments rather than constantly reinventing the new. How do you think about computing history and its importance in how people should be building software or thinking about kind of the future of computing?
I think it's how could I say that? I think the computing history until very recently, and I think still a lot of people would challenge that, was not seen as real history.
Mhm.
People would not think of computing history as a field because it's so new. And because it feels, many of the actors that participated in the microcomputing revolution are thankfully still alive, like Alan Kay, for example, or Ted Nelson. Those people are here walking the same earth we are, and you can actually talk with them. And so I think it's a very different kind of history. And I think, as you say, like, because computing history is basically a subpart of the consumption society, people think of computing history only through its artifacts. The Macintosh SE, HyperCard, the games, LucasArts point-and-click games, all of those things, all the symbols of computing history. But what is super interesting in computing history is actually to look at the actors and the movements. And for example, the fact that people from the public labs gradually flock to the private labs, like if you go through to Bob Taylor and the Xerox PARC, and then the Xerox PARC with Alan Kay, Adele Goldberg, Alvy Ray Smith, and then you look at how they disseminated Alan Kay at Atari, then Apple, Alvy Ray Smith with Pixar, the number of actors that actually played a significant role in computing history, you can almost know all of them. Like, it's not that many people. That is crazy. And you have all of those very weird bouncing things happening. Like, for example, you mentioned the Commodore VIC-20. The Commodore VIC-20 was designed at Commodore, and then its follow-up, the Commodore 64, was designed by an engineer, almost by himself, called Shiraz Shishvi. And some other people worked on the chipset, like the SID chip, the VIC chip, like the video chip, the sound chip, all those chips. But Shiraz Shishvi basically created the Commodore 64. Like he was the main engineer. And he was very faithful to Jack Tramiel, who was the founder. And when Jack Tramiel had a showdown with the board of Commodore, he went out and he took Shiraz Shishvi with him, along with the 1632-bit microcomputing project, and he bought Atari. And so the Atari ST should have been a Commodore computer, but became an Atari computer because of that, because of the fact that Jack Tramiel left and bought Atari afterwards from One Air Communication. And the Amiga was created as a startup.
Right.
Funded by Jay Miner, who had created the Atari 800 at Atari. Then he created Amiga, and Atari was bought by Commodore. And so the Amiga, being really an Atari-like design, became a Commodore computer. And I think this is those things that we need to look at. We need to look at the movements of the people and the movement of the ideas that underpins the microcomputing revolution, because those movements can give us grid to look at the tech industry of 2026. And I think this is when I speak with engineers, when I speak with people working in tech, you can feel that they have a sense that they kind of know, about the Mac, about Steve Jobs, about the Apple II. The rest is a blind spot. And when I talk with them, they're all like, I would love to know more about that stuff because it would inform my work. And so I think that looking at computing history for me is much more about looking at how we can build that grid and how we can look at certain moments and, almost take a slice like we do with ice to date something. And for example, look at years like from 1982 or 1983 until 1993, you could buy an Apple II or a Mac. You could buy computers at all sorts of price points. And I think it's the sociological impact of computing and how it was received in different parts of the world. Like, for example, it's fascinating for me that, that in the US, computing followed Moore's law strictly. Like computers got bigger, better, and actually, or rather on the, the Moore's law, like basically on the same,
right, in terms of like the computational power.
Yeah. It followed that trend. And then in Europe, where we had that trend of very tight integration, like the VSLI chips of the Sinclair microcomputer or the Acorn computers, we see ARM. We see ARM appear in Europe. Why? Because Europeans, I don't know, think about innovation in a different way. And so that morphology of ideas, that morphology of computing, of machines, is really what I'm, passionate about. And again, I don't know if that answers your question.
No, this is fantastic. Yeah, and I love like the focus on kind of like the intellectual history of computing rather than just these artifacts, and like seeing kind of how the ideas spread and change, and then sometimes like ideas that are really, really interesting and then just become dead ends, which often means like these are things that are maybe worth reconsidering. I know you've and we've talked a little bit about the Canon Cat, which like has like very interesting ideas around kind of manipulating files and information and data and stuff. And I feel like that's one of those really cool ideas, but it kind of just didn't really go anywhere for quite a long time after the Canon Cat.
That if you look, the closest thing to the Canon Cat today as a hardware, not as a software philosophy, is probably the MacBook Neo. Like there's no configuration. You can just buy it. There's only one model. There are 2 ports. It's an appliance. You can buy it it's very funny. I thought about that when Apple introduced it a few weeks ago, but Jeff Raskin in the Macintosh papers, who are the papers where he really talks about like how we should build computers for people. And he actually say we need to build a computer for pits, people in the streets. And he says, he outlines a few principles, and he says it's better to have several colors than to have several memory configurations. And so I think the Raskinian ideals actually took over and has won. Like if you look at the success of Apple, I think it's a very, in terms of hardware, they were very Raskinian in their philosophy. But in terms of software, it was a complete dead end because I don't know. I think the how could I say that? The players were already set, And Steve Jobs, I think, in a 1995 interview, says about next hardware specifically, we knew we would be the last to make it or the first that would not make it. And actually, they did not make it because the market was already saturated. And I think Raskin's the same thing. Just like Jean-Louis Gasset said that the Apple II GS, he knew that the Apple II GS would be dead in the water because Microsoft said, we're not going to port any of our business software to that machine. So it was stuck in that very small corner of the market, entertainment, education, and it's a good success. But it's the last of the Apple II line because Microsoft would not support it, and also Apple tried to kill it. So I think it's very interesting to see all of those things that could have been, as you say, like the Canon Cat, or there are many others like the PCW from Amstrad, like all of those machines that try to make computing as approachable as possible, and are actually embodied the ideals of plug and play, for example.
That's interesting, right? And you mentioned like this idea of like the appliance and like Jeff Raskin, like that was I think that was originally his vision
Yeah,
of the Macintosh, and then kind of Steve Jobs came in and kind of changed a little bit about what it ended up being. But right, and then he kind of took the original vision and tried to embody it in the Canon Cat. Right, and now Apple seems to be doing those kinds of things like once again,
yeah.
which is pretty exciting. So, and you were mentioning about like vibe coding and programming, and of course, I mean, programming has changed a lot. What are kind of the I guess the constants within programming, as well as the things that have changed over time, even kind
Yeah.
of in our age of vibe coding and AI generated code?
Mm, it's funny because I think how could I say that? The basics haven't really changed. Like, for example, I have a friend, like yesterday, he asked ChatGPT to create a game for him, inspired by all of those like Street Fighter 2 type of games, like two people
Yeah, yeah.
fighting, very, very simple commands. And the game is a single HTML file. And today, like I think he played around with it for most of the night, and now is understanding that, oh, if I want to make that game this and this and that, I need to break it into several files, and I may need to use other technologies. And so I think this is still true. Like in the 80s, for example, when you were buying a Commodore 64, an Apple II, an Atari 800, any of those 8-bit machines, when you would turn it on, you would be faced with a basic interpreter. Like you would be able to input basic comment. And it would generally begin with a hello world, like 10 print hello world run. Like you had those programs, and then you would understand, like, I do have to number the lines if I want to be able to reread my program. Oh, actually, it would be better to break it into several different files. Like, I think the structure, a lot of things that don't have to do specifically with code, like how you organize the project, how you make it readable, how you comment it, are what hasn't changed. And otherwise, what has changed is that we've basically gone up in terms of the abstraction. Nobody writes assembly anymore, or how the number of people that writes assembly is uh, did not grow as fast as the rest of
Right. It is a very it's a
yeah.
shrinking and vanishing fraction of programmers.
Exactly. And we do need people that write in assembly. Like we rely on people writing in assembly for many operations that are key to the way our computers function. But you need maybe, I don't know, 100,000 people writing in assembly. And now 2 billion people will get access to those very simple, HTML and JavaScript project. So I think actually a lot hasn't changed in terms of how you can learn how to code. I do lament the fact that one thing with vibe coding is that you're talking to the model in English and it's outputting in JavaScript or in HTML. What I really like about the 80s machine is that you're talking to them in BASIC and they're answering in BASIC. And so I think the very nice thing about those machines is that you can, you could interrupt the program, observe it. The barrier of entry, like very fast, you could learn what is a language and which commands produce which effects. And so I think that you could actually get better. Like people now, when they learn how to write code with agents, are getting better at telling the right things to the agent so it performs according to their desire. But they will never look at what the output is. They will not look at the code. I think this is the problem. If we solve this, then vibe coding and agents are great news for everybody. Because when you look at how developers use them, because they know how to write and read code, they get that that an enormous boost in productivity. For other people, they get the opportunity to write software, which is amazing, but they don't understand how it works technically. And in the 80s, when you would open like for popular computing, or when you were Compute or those kind of magazines, or in France we had Hebdo Logiciel, you had listings of basic programs and a comment about this comment does that, this comment does that, and this is what you need, this is what you want to use if you want to have that effect, that color, that half color, that sound, if you want to poke in the memory at that spot, which will produce this effect. This is what we like right now. The rest hasn't changed that much. Computing, like programming, is in my opinion, right now in a very interesting shape. I'm not a doomer. I think, it's a new abstraction layer. I think Linus Torvalds said it very well when he said, think of the AI coding agent as we thought of compilers in the 80s. We moved in the abstraction
It's like a
ladder.
higher level, yeah.
Yeah, we stopped writing assembly. We wrote C and C would compile. And now people write C and it's good. But I think we need the education. We need to push people to not only, this is the magic of HyperTalk in HyperCard.
Right. I was going to
You
ask
know,
you about, yeah, HyperCard and kind of like the whole
yeah,
like democratization of software. Like, I feel like we're close, but we're not
yes.
quite there yet.
There are two paths forwards. And again, in AI, the thing that is very, you can marvel at the prowess and be very concerned about the actors. And this is where I am right now. I think people, I'm not working with those companies, by the way, but we're using their software, but I haven't spoken with researchers or with people inside those companies. So what I say is strictly me, but I feel like they're interested in more people being able to produce more software for their usage, for many, many things, for, tailored workflows, for many good reasons. But it does not look like they're interested in people getting good at programming itself. And so I worry that the dream of HyperCard, which is malleable software and user programmability, becomes disposable software. And that has me very worried because it can go both ways. If it goes in the way of now we have software that can run on our machine, we can fine tune it, we can actually make it more accessible for people that need simpler interfaces, or we can actually add more tools and we can get that small talky way of doing software, that HyperCard way of, you get a stack from HyperCard and the stack is the program. Like you can open the stack up, lift the hood, modify it, it becomes your program. That's awesome. But if we just get, people prompting Claude to create stuff and they don't know anything about how the stuff works, I think it's not good. The magic of the 80s computers like the Apple II is that you can open them up. They were very, like a computer from the early 2000s now will probably, if you take it off the streets, like you find it in a bin, it will not work. Like the battery will be dead, something will have leaked on the motherboard. An Apple II is a tank. And I think this is how we should think of those coding agents. They need to be Apple IIs. They need to be observable. They need to be end user programmable. They need to come with great documentation. And the agent should actually tell you, here's the output. And by the way, here's how it works. Like here's the diagram. So this is kind of how I feel about that.
No, I like this. And as you're talking, and because like there's the whole idea of like the low floors, high ceilings kind of thing.
Yeah.
And I feel like though the end goal is not just a high ceiling with this open-endedness and things you can make. Like you want it to also have a ladder that allows you to kind of reach that high ceiling, but in a way where you kind of understand every single rung. And I feel like right now, for people who already know how to program, some of that is possible and is already available. But for people who are just using it to generate software, it feels very black boxy and kind of closes off questioning rather than kind of allowing you to have further kind of questioning and understanding.
Yeah. And like when you look at HyperCard, and you can try it on the Internet Archive, and when you look at HyperTalk, the thing that is amazing with HyperTalk is that it is so close to English. Mm-hmm. Honestly, writing on mouse down and then on mouse up, everybody understands this. Like on mouse down means when I click, something will happen. On mouse up means when I release the click. Like this is so clear. And so I really hope that we can find a way. I would much rather have to write prompts twice as long, but that gets me closer to the abstraction rather than having a better, a faster output. Because I think this is the key. And I know this is why I don't, I'm not at OpenAI or Anthropic, and I probably would be bad business for them. But I think this is the way to get better programs and to actually get programs that will not be disposable, that will not be thrown away. Some people will tell you, well, I don't care if my program is thrown away. Maybe I don't, maybe I just need it for a period of 3 or 6 months. True, but my work at a nonprofit trying to preserve the history of the digital, of the microcomputing revolution proves to me that actually, if you do not get software, if you do not find a way to have software that can outlast you, nothing is preservable. Nothing. We've gotten, some people, some developers entrusted that nonprofit organization with code from games that they had worked on in the 80s and 90s. If you don't have the development kit, you cannot read the code, you cannot compile it. And so I think now is the era where we can finally have software that can, maybe upgrade itself so it stays current. But I'm dismayed to see that, playing games from the macOS 9 era, which is 20 years ago, is harder than playing games from the C64 era, for the same reason that, a C64 is a tank and an iMac or a Power Mac G3 are much more sensitive machines because they're much more advanced. I'm very worried about that we will get files that will have been outputted by software that will have been generated on some one machine, and that file will be lost forever. And I think you know about that, but basically the chronology of media, paper actually outlasts software. So
Wow.
I think
Yeah.
this is a very interesting and very, it's a now problem. It's going to be a real problem, real issue. It's the same problem that makes, banks hire COBOL programmers.
Yeah. And so related to this, I feel like part of this is people are optimizing for maybe ease or power of software or something, like just kind of like doing more or making it easier to do more. And when you're talking about these things, you're thinking much more about sometimes those considerations, but other considerations as well, such as preservation, making sure you can kind of understand things, making sure even separately, just like some of the things we're talking about earlier, like with the like non-multitasking, like the idea of like that people can kind of be present and focused on whatever the task is at hand. There's much more of these, like a whole slew of like human considerations that I feel like
Yeah.
sometimes are lost in our pursuit of just kind of more computing sophistication. How do you kind of think about those balances? Because you and I have talked about, and there's kind of some people from like maybe like the humanities side of the world who are like, oh, this stuff is all terrible, and the people in the tech world are saying no, just like pedal to the metal. And clearly, at least from my perspective, and I think you agree with me, is like there's a very large space in between that has sort of been ceded to both of the extremes. And yeah, so how do you kind of think about what are the right considerations that we should be thinking about when we're building software and building hardware that will last and kind of make us better versions of ourselves?
Yeah. So I fully agree with you. And I think the tech industry gives itself justification for the pedal to the metal argument because of the way the big corporations are handling, for example, operating system releases. I still haven't figured out why we need yearly updates of macOS or iOS. I honestly don't understand. I have never felt the benefits. And again, like my father in 2002, when he was having that iMac came with macOS Jaguar, which was not the best macOS 10 release by far. It was very early, but he never upgraded it. He needed to open his email, to use Apple Works at the time. It was not HiWork, to go on the web, to do some other things, even some complex stuff. And that machine was stable. We never upgraded it. Software would work for it. And now, again, like to go back to the native development argument, like when we started to work on Kosmik, the software I worked on, we were using, I think, Swift 5 or Swift 4. And every year Swift syntax would be updated, which is madness. A language should be stable. And so I believe that the problem, and I worry this will not happen, is we need, and I think Ubuntu does that very well, we need long-term support. Like if we want developers to slow down and actually take into consideration old machines, old operating system versions, all of those things, we need to say, okay, we're going to upgrade those operating systems, those machines for the next 10 years, which is what Apple has kind of started to do. And now, for example, they're still, I think, shipping security patches for iOS 17. But this is why I think what we want to see in the tech world is so hard to do. It's because you're always on send. Everything is moving below your feet. Like Windows is updating constantly, macOS is updating constantly. And as a developer, you have to keep up. And that actually, I think, slows down progress. Because, for example, at Kosmik, when we were doing a Swift application, we were spending so much time like, okay, now Apple has introduced APFS. So the CI is not working because the machine uses HFS+. And so now we have to upgrade all the tool chain. Think for a minute, like a seed stage startup, which in our case at that point had raised 700K. We lost 2 weeks, going from Swift X to Swift Y and to upgrade that toolchain. So I think we should say, okay, there is a base layer. And now with the AIM chip, for example, with all the chips that we have in our machines, like a Mac from 2020 is plenty fast for today. Like again, the MacBook Neo is basically in single core, it's an M3, but in multi-core, it's an M1. And it's fine. It's fine. Now we just need the software to do the same. We need the equivalent of the M series chip of Apple Silicon for the software. It needs to be stable, so we know there's an environment that will not move. Like if you look at macOS, for all of its faults during the non-Steve Jobs era, macOS 7 was supported for such a long time. It's, it worked on machine with 68K processor running at 8 megahertz up to, I think, pre-G3 machines that were already in the 100 megahertz category of computing, which is widely different. And it worked fine. Like you could run Apple Works on a Mac Classic 2, but also on a Power Mac, which was based on a PowerPC architecture. This has disappeared. This does not exist. The only developers that are working tirelessly to support a software that is 10 years old are the people, for example, working on VLC. Like there is an interview from the people working on VLC recently, and he was telling how hard it is to support Windows XP, iOS 9, and all of those machines. It shouldn't be. I think if we need to solve the underlying issue to get to that point where we can say, okay, there is a stable platform. We can build on top of that. It's fine.
And so maybe you can talk a little bit about your experience with this nonprofit and kind of thinking about preserving these kinds of things. Well, and actually, maybe you can also start, because you mentioned, and you were very young when you got your first Atari machine. When did you start working with this organization? Like, were you also basically that age?
Yeah, I was. So I got a computer when I was 8, and I joined the nonprofit when I was 11. And I actually called the guy that had created it, and I think it was 50 members at the time. And when I called him, because his cell phone, which tells you it was a completely different time than now, his cell phone number was on the homepage of the website. So I called him, and I was a child, and he thought it was a joke. And thankfully, he lived in Paris, and I also was in Paris. And so we met, and he was like, "You're real." And so we became friends, and he basically taught me everything. And basically from when I was 11 until I turned almost 18, I would go to the warehouse where we were storing all of the machines and restoring them every Saturday afternoon for 2 to 5 hours, repairing things, trying things out. And they even had, at some point, we had to bring in hackers from the 80s to break the security measures that had been put in place on some games to preserve them, because we could not access the code. So it's a very real issue. It's a real problem.
So interesting.
Yeah, it's and some companies actually called us because they were like, we have floppies from the late 1990s. We don't have any computer with a floppy, but we kind of need that thing because, I don't know, we have an audit, or we need to do support for a very old project. So it's a very real issue. And so it was amazing to work with them, and I owe them everything I do now.
That's amazing. And so are you still affiliated with the organization?
Yeah, I'm still a member. Unfortunately, I don't have the time to go there as often, but I think now it's 300 members.
That's amazing.
So it's thriving. The only thing that and I know in the US you have the Computing History Museum. Like, it's in the US you are the birthplace of the computing, microcomputing revolution and the computing revolution. So of course you have the Computing History Museum and you have those institutions. In France, when you say to people, we need to preserve microcomputing history, they don't really understand what you mean. And they will always push you towards video games, which is fine. Like, it's a very big part of computing history. But I'm very worried that we haven't grasped yet the fact that we do need to have copies of HyperCard. We do need, the Internet Archive is so important. We do need to have working machines. We do need to have people that repair them. It's important. Those artifacts are important. The people that created them had ideas and ideals. We can still talk with them. We can write that history, and we absolutely should before it's too late.
Yeah, no, it is vital. And going back to what you were saying of like talking to people in the tech world who are not familiar with a lot of this history, and especially like the intellectual history, like the history of the ideas and kind of how they interrelate and kind of cross-pollinate and spread. I would love it if they were kind of involved in this kind of preservation, but first they kind of need to understand a little bit of it. Like, how do you, like, what are there things you point them to of like, oh, here are the resources to kind of get you excited about these kinds of things, or to better understand this kind of information?
I think so. Of course, there is one good thing, which is that Apple has remained extremely constant in the computing world, even more so than Microsoft. I think in how could I say that? I think people have that image of Apple. And so when you show them a Macintosh, and Apple has been recently very, very smart in how, for example, they put an old iMac in the ad or an old Mac. And so I usually point people to a Mac SE with HyperCard, an iMac G3. At the browser company, I think they had iMac G3 in their offices. So
Really?
I think, I think, just to show like,
Yeah, sure.
this is the internet computer. So we should take cues from that. So this is usually where I point people to. Atari, for example, it's very funny because people have an idea. They're like, oh, that's the video game company. But when you're like, they also built extremely interesting computers. They don't really care. Commodore had 51% of the market in 1986. It was $1 billion company before Apple, a year before Apple. Nobody knows anything. The founder of Commodore spent the 5 years of the war at Auschwitz. He walked through Europe and then crossed the ocean, enrolled in the US military, learned English on his own, started a typewriting repair shop in the Bronx, imported office furnitures and typewriters from Italy, and became basically that most important character in computing history for 20 years. Steve Wozniak and Steve Jobs actually tried to sell the Apple I design to Commodore. And we don't know anything. Of course, there are books like Brian Bagnall wrote amazing books on Commodore, but I mean, it's not in the popular culture. It's not in the popular tech ecosystem. And so I think that we need to point people, for example, like you can point them at HyperCard and say, this is actually PowerPoint and Paint and all of those software that you think about, plus code in that small floppy, and you can build games with it. And they will usually have that click where they're like, oh my God, we have progress, but not that much. And then you can say, Bill Atkinson, who worked on HyperCard, also worked on that machine and worked on that. And so because you have that concentration of characters, you can actually get people super interested if you just find a way to pull the thread. And I think the early Macintosh machine, because they're cute, because they're extremely popular, because they've been in The Simpsons, they've been everywhere. People know what it is. It's a very cool thread to pull. This is where I would try to start.
Okay.
And you can actually say, here's the lineage. And what's very interesting in Apple history is that the metaphors were actually preserved through the technological transitions. And actually, Apple got through many, many, many more technical transitions than Microsoft. They went from Motorola 68K processor to PowerPC to Intel. And between the PowerPC and Intel, they went from their own kernel to using BSD basically and rebuilding an OS. But the metaphors stayed very consistent. And so you can say to people, it's very interesting even philosophically, like that kind of ship of Theseus thing with the Mac.
Yeah, right.
So,
underneath everything's changing, but it kind of looks
Yeah.
at least somewhat, it kind of it preserves that kind of, the metaphor in the user interface. Are there any books or like reading materials you would point people to as well to kind of help them learn about these kinds of things?
Yeah, so I think The Dream Machine to get a hang of the very, what I would call the antiquity of computing history, like those, like GCR, Licklider, Bob Taylor, all of those, Larry Tesler, all of those people, they are the equivalent of Plato, Aristotle, and those kind of people. Like they create Douglas Engelbart, they created the concepts. They basically set the course. We're still living in their world. So for computing, as with a big C, I would point them to that. And for microcomputing, I think there are many books for Commodore. The Brian Bagnall books, like Commodore Company on the Edge, is amazing. But there is a very good book. It's very interesting you can find it online, or you can buy it on AB Books or somewhere like that. But West of Eden, which is the history of the early days of Apple, is amazing. There are many, many, many other books that people can read it. I think Sinclair and the Sunrise Technology is a very interesting book about entrepreneurship in Europe and how microcomputing was thought about in Europe. I think your own book, The Magic of Code, is a very good introduction to how computing evolved as a language, as how the metaphors evolved. And there are the other classics, but I think those are the best to get started.
Thank you. And then maybe as a last question, I mean, you mentioned HyperCard a lot as one of these like interesting touchstones that people might not be aware of, but can really kind of inspire them. Are there any other like software, hardware, computing touchstones that that people kind of have forgotten about, but you would point to as like, oh, this is something that people need to realize is like unbelievable?
Yeah, there are many. Cyberdog is very interesting. That idea that the web could also be a real space for the user. I'm hesitant to say OpenDoc because it's very ambivalent, but I think OpenDoc is marvelous. as an idea, because I think it's honestly almost the last time a big company really tried to change its ways. The fact that people at Apple would say, okay, we're going to replace the file menu with a document menu. We're going to maybe destroy our third-party software business, but we're going to create that new kind of documents that blends together application and documents. And we need to do it because that's the way forward. I think is amazing. I think people, I think early versions of Automator are really textbook. Look at Automator in early versions of macOS 10, and you see that anyone can actually learn how to script and code. I think GarageBand remains something that is extremely inspiring. And in terms of software, I think those would be my top picks. If you expect the really weird beast, like I think the early Lucas Arts games like Monkey Island, Day of the Tentacle are extremely good in the way. If you think about it, people are like, yes, they're just point and click. Yes, they're point and click in 1986. The mouse was just democratized.
Right.
And people would play with the mouse and not the joystick or not the keyboard. It's amazing the way they thought about that, the way how interactive it can feel, yet extremely approachable. And so, yeah, I think those are examples that I really, really, really like. And otherwise, thankfully, in the modern world, in today's world, there are labs like Ink and Switch or independent researcher like Alex Obenauer who are doing amazing work in terms of what is a composable UI, actually, what is a metaphor, what is a spatial canvas, what does it mean to have a 3D user interface, what is CRDT and why is it important? And I'm very thankful that those things exist and that those people are doing that work. And I wish we had more of them. And I think the best way to get more of them is to actually get people interested in computing history so they can open their minds to I'm not forced to create the nth B2B SaaS software.
I love this. That is hopefully unbelievable fodder for inspiring lots of people to think much more broadly about how computing can be. So yeah, Paul, thank you so much. This is amazing.
Oh, thank you. Thank you so much.